I've made this video because I noticed that a lot of people really struggled with net ionic equations during their tests, and I want to make sure that you have it right before the exams, because net ionic equations are in the exam. So there are several steps involved. None of the steps are hard, but you have to make sure you do them all correctly. The first step is writing a balanced chemical equation for the reaction. You won't get the net ionic equation correct if you haven't balanced the chemical equation appropriately. The second step is to rewrite in ion form any dissolved strong acids or dissolved ionic compounds. So the strong acids are hydrochloric acid, sulfuric acid, and nitric acid, and the ionic compounds are anything that has an ionic formula, so a metal and a nonmetal. They have to be dissolved, so you can identify them being dissolved by having the aqueous sign after them in the chemical equation. So the next step is to remove any spectator ions. This involves reducing by an equal number any ion which appears on both sides of the equation until it is gone completely or only present on one side of the equation. The fourth step is to write the equation without the spectators, and then you need to check if it's correct by ensuring that the elements and the charges are balanced on either side of the equation. So let's look at our first example. This one is written as a description of the reaction, and you have to write the unbalanced equation and then balance it first, so there's an extra step. The example says solid aluminium hydroxide reacts with a solution of sulfuric acid to form an aluminium sulfate solution and water. So we can write that as follows. An important step here is to write out your ionic and molecular formula correctly. So you needed to know the charges of each ion in order to do that. So once you've written out your unbalanced equation, then you're going to balance the equation by placing coefficients in front of the appropriate molecules. Now it's really important in this step that you balance it correctly, but we're not going to go into how to balance an equation. We've done that enough already. So once you've done this, then you're going to identify the strong acids and the dissolved salts and rewrite those as ions. So here we have an ionic compound, but it is a solid, so we're going to keep that as a solid when we rewrite our equation. It's not written as ions. Here we have sulfuric acid, so that will be rewritten as ions. Here we have a dissolved salt, so this will be rewritten as ions. And here we have water, which is a covalent molecule. It does not contain ions, so do not draw it as ions. Your equation should look like this once you've written everything that requires to be ions as ions. So you'll notice that the coefficients are appropriate for the number of that atom in the molecule. So we have 6 hydrogen ions because we have 3 molecules of sulfuric acid, and each molecule of sulfuric acid produces 2 hydrogen ions. The same goes for all of these. So once we have written our equation with our ions, then we need to remove the spectator ions. So those are the ones that are the same on both sides of the equation. So you can see here that the sulfate ion is present on both sides. So when we rewrite it, the sulfate ions must be removed. That's done here. The last step is to check that the charges and the elements are balanced. So we can go through and ensure that there are 2 aluminium atoms on each side of the equation. There are 1, 2, 3 times 2, so 6 oxygen atoms and 12 hydrogen atoms on either side of the equation. It's also important to make sure that the charges are balanced. So we have a positive 6 charge on the reactant side and a positive 6 charge on the product side. The next example we're going to go through a bit quicker. This net ionic equation has been provided as an unbalanced chemical equation. So the first step is to balance that using coefficients. The next step is to identify the substances which are strong acids and dissolved salts and rewrite those as ions. So we have hydrochloric acid, that will be rewritten as 2 hydrogen and 2 chloride ions. We have sodium carbonate. This is a dissolved salt, so it will be rewritten as 2 sodium and 1 carbonate ion. We have carbon dioxide gas, which is just a gas, so it's not rewritten as an ion. Water, obviously not ionic. And sodium chloride, dissolved. So this one, rewritten as 2 sodium and 2 chloride ions. The next step is to remove the spectator ions. So you can see that on either side of the equation we have sodium, get rid of those, and we have chloride, get rid of those. We then rewrite the equation without the spectator ions. That's provided here, and you can check that for yourself that it has the same total charge and the same number of atoms on either side of the equation. The last step is, the last example is acetic acid reacting with potassium hydroxide to produce water and potassium acetate. So we need to balance the equation first. In this case, we're lucky and the equation is already balanced. The next step is to rewrite the strong acids and dissolved salts as ions. Even though this is an acid, acetic acid is not one of the strong acids, so we keep that as a molecule in the final equation. The potassium hydroxide is dissolved, and therefore we write that as a potassium ion and a hydroxide ion. The water obviously is a molecule, does not contain ions, so that kept the same. And then we have the potassium acetate is a dissolved salt, so we write that as a potassium ion and an acetate ion. We're then going to look for our spectator ions, that is the potassium ion, which is the same on either side of the equation, and we're going to remove them. We can then check that the charges and the elements are balanced on either side of the equation. Now before I stop, I'm just going to mention that the reason that we remove the spectator ions is because if they're the same on either side of the equation, that means that they're not reacting, they're not involved in the chemical reaction, so we don't include them in the chemical reaction. They're still present, but they're just sort of spectating or watching the chemical reaction occur. I hope this helps.